Hey everyone, welcome back to the College Algebra playlist. In this video, I want to talk about 4 special patterns that arise when we look at factoring problems. Alright, the patterns are perfect square trinomials, the difference of squares, and the sum and difference of cubes. Alright, so let's dive in. Okay, here we go. So we're starting with factoring perfect square trinomials. Alright? So we've seen these before, right? In a previous video, we showed how to do a plus b squared, right? That's a plus b times a plus b, right? If we FOIL that, we get this perfect square trinomial here. A squared plus 2ab plus b squared. All right, so we're reading this from left to right, like it's a sentence in English, right? And we're starting with 2 factors, right? A plus b times a plus b, and we end up with 3 terms, right? But we know that when we have factoring problems, we're trying to do the reverse of that, right? We start with terms and we want to end up with factors, right? A plus b times a plus b. Okay? So that's what we'll do in this video, right? We'll start with these terms and end up with these factors. Here I'm asked to factor x squared plus 6x plus 9. So we suspect that this is a perfect square trinomial, all right? But before we declare it as one, we need to check a few things, right? We should have a squared plus 2ab plus b squared on the left-hand side, all right? So let's figure out what a and b are. We notice that x squared and 9 are perfect squares because x squared equals x squared and 3 squared equals 9, okay? So we have our a and b. We have a equals x and b equals 3, all right? So we have all the pieces we need to check to see if we can factor this as a perfect square trinomial. We need to check this middle term, right? The middle term should be 2ab. So we're asking, is 6x the same thing as 2 times x times 3? And the answer is yes, it is the same. Okay, so this is a perfect square trinomial, which means we can factor it as a plus b squared. X plus 3 squared is our answer. All right. Let's do one more. 49x squared minus 14x plus 1. We have our formula down here, right? We just need to figure out what a and b are. Here, a in blue is 7x. Okay, we're squaring that entire thing to get 49x squared. And our b in red here is negative 1. Right? We're squaring that whole thing to get 1. And you say, Luke, why is this negative, right? Why do we need this to be a negative number? It's because this middle term is negative. Right, so we need the outers and inners to add up to give us a negative number. Okay, so if we choose one of these to be negative, we'll get what we want. Okay, so a equals 7x and b equals negative 1. All right, let's check the middle term. Is negative 14x the same thing as 2ab times 2 times 7x times negative 1? All right, and the answer is yes. Yes, it is the same. Okay. So this is a perfect square trinomial, all right? So we can just do a plus b squared, all right? So our answer is 7x minus 1 whole thing squared, okay? Next, let's move to the difference of squares. Okay, once again, we've seen this already, right? We've done this before. We had 2 factors, right? A plus b times a minus b, right? When we FOIL that, we get a squared minus b squared, right? We get terms. Okay, so I'm reading it from left to right. Right, we start with factors and we end up with terms. All right, but we want to do the opposite in this video, right? Start with terms and get factors. Okay. So here we're asked to factor 9x squared minus 25. This is the formula we're going to use, right? This is the difference of squares. Okay. 9x squared and 25 are perfect squares, because 3x whole thing squared equals 9x squared, and 5 squared equals 25. Okay, so we have our a in blue, right? A is 3x, and b in red is 5. Okay, so we have all the pieces we need to use this formula. All right, 9x squared minus 25 equals 3x plus 5 times 3x minus 5. Okay, so this is our answer. Let's do one more. Here we have 81y squared minus 100. Okay? we can use the same formula, right? And we notice that 81y squared and 100 are perfect squares because 9y whole thing squared equals 81y squared, and 10 squared equals 100. Okay, so a equals 9y and b equals 10. So we have 81y squared minus 100 equals a plus b times a minus b, right? 9y plus 10 times 9y minus 10. And that's our answer. Okay, now let's move to the sum and difference of cubes. All right, this is the formula that we have for the sum of cubes, right? If we have something cubed plus something cubed, we can factor it like this. Okay, and the difference of cubes formula looks super similar, right? The variables are arranged in the exact same way, right? We have a, b, and then a squared, ab, and b squared. The only difference between the two formulas is the way we arrange the plus and minus signs. Okay, so we need to memorize these formulas to use it on tests and things like that, right? And what we can use is something called SOAP, right? We can use the SOAP mnemonic device. Here's what SOAP means. We arrange the variables the same way, right, for both formulas, right? Look at how these are identical. They're arranged the same way, right? But we don't know what goes in these slots, right, for plus and minus signs, right? That's hard to remember. So SOAP will help us with that. SOAP stands for same, opposite, and always positive. All right, so we look at this plus sign here, right, and we say, okay, in this slot we'll do the same, right, we'll do plus, and then in this slot we'll do minus, right, the opposite, and then this slot here is plus, right, this is always positive. Okay, so SOAP helps us remember how to fill in these empty slots with plus and minus signs, right? Here we have a cubed minus b cubed, right, so we'll do the same, right, that's minus, and then opposite, that's plus, and then always positive, this is plus. Okay, so let's try an example. Here we're asked to factor x cubed plus 27. This looks like the sum of cubes to me, right? I suspect that this is the sum of cubes, right? So I'm going to use this formula, right? This is incomplete, right? This is all I remember how to do, right? I only know how to arrange the variables. Right? You say, Luke, what do we put in these empty slots as far as plus and minus signs? All right, and I would say use SOAP, right? Use SOAP to fill in those slots. We have a plus here, so we'll do the same, plus, and then opposite, so we'll do minus, and then always positive, right? So we'll do plus. All right, that's how we can use SOAP to remember this formula, right? The sum of cubes formula. All right, x cubed is x cubed, and 3 cubed is 27. All right, so it looks like we found our a and b, right? A is x in blue, and b is 3 in red. Okay, so we have all the pieces we need to factor this. Okay, so we have x plus 3, like starting to factor this, right? We have a plus b, right? So we do x plus 3, and then we do a squared minus ab plus b squared. All right, that's x squared minus x times 3 plus 3 squared. Okay, we can clean this up a little bit to get x plus 3 times x squared minus 3x plus 9. All right, and that's my answer. Okay, let's try one more sum of cubes, right? 8x cubed plus 125 is the sum of cubes. All right, so this is the formula we're going to use. All right, let's find a and b. 2x whole thing cubed is 8x cubed, and 5 cubed is 125. So a is 2x and b is 5. All right, we have all the pieces we need to complete this. Okay, let's start to factor it. 8x cubed plus 125 is 2x plus 5 times 2x whole thing squared minus 2x times 5 plus 5 squared. All right, notice the use of parentheses here. I'm trying to square a, right? I would need to square that whole thing, right? So it's important to use parentheses here, right? 2x whole thing squared is 4x squared. All right, so we've completed our factorization. This is our final answer. All right, here we have the difference of cubes, x cubed minus 64, okay? Once again, we can use SOAP to fill in these empty slots, right? This is all we remember, right? So then we can use SOAP to help us out, all right? This is a minus sign here, right? So we'll do same, we'll do minus here, and then plus here, opposite, right? And then always positive. Okay, so this is our formula. Let's find a and b. A is x, right here in blue, right? And b is 4 in red. Okay? So we have the pieces we need to complete this, right? So let's start to factor x cubed minus 64. All right, it says a minus b, all right, so we'll do x minus 4 times a squared plus ab plus b squared. All right, so we have x squared plus x times 4 plus 4 squared. And this gives us our factorization. Okay, let's do one more example. Here we're asked to factor 1000y cubed minus 1. Okay, we're going to use the same formula we just used, right? This is the difference of cubes, okay? And 10y, whole thing cubed, right? That equals 1000y cubed, all right? We have 1 0 here, right? So when we apply the power 3 to it, we get 3 zeros, okay? And 1 cubed is 1, okay? So a equals 10y and b equals 1. All right? Let's start to factor this, right? A cubed minus b cubed is a minus b, right? Times a squared, right? That whole thing needs to be squared, plus ab plus b squared. Okay? And we can clean this up to get 10y minus 1 times 100y squared plus 10y plus 1. All right? So this is my final answer. That does it for this video. Thank you for watching, and like and subscribe.